Assalamualaikum everyone. My name is Mohammed Numan Alam. Welcome to my YouTube channel. So here in this video we will start over problem number 3.14 from the Walpole book. So here we can see the waiting time in hours between the successive speeders spotted by the radar units is a continuous random variable with CDF is given. I mean the cumulative distribution function is given by, you can see here this function. The capital F of x is 0 when x is less than 0. Otherwise x greater than equal to 0. We have this function 1 minus e raised to the power minus 8x. To find the probability of waiting less than 12 minutes between the successive speeders. So first part we will use the cumulative distribution function of x. In the second part we will use the PDF, I mean the probability distribution function of x. So here we can see the important part is, we can see the waiting time is given in hours. So here this is my random variable capital X is defined in hours. And now we can see the important point to find the probability of waiting time less than 12 minutes. So here in the first part, so we will find the probability of x is less than 12 minutes, right? So but the important thing is here, because my capital X is given in hours, so first we will convert over minutes to hours by dividing by 60, right? So this means in the first part, how I can find, so because I required the probability of x is less than 12 minutes, so we will divide by 60, right? So this means I can write the probability is x is less than 12 by 60. So this will give you the probability of x is less than 0.2 hours, right? So first we will convert over minutes to hour. So how we can divide by 60, because we know that 1 hours contain 60 minutes. So now in this case we are going to find this situation, probability of x is less than 0.2. So now if you remember this formula, here I am writing, we have already learned this. So we know that whenever you have the probability x is less than equal to x, so we can write the capital F of x. We know that because we are dealing the continuous random variable. So if you remove this equality sign, so it's the same, okay, right? So this means I can write what? So I can also write the probability of x is strictly less than x. This is also equal to f of x. But in continuous case, you know that whenever you deal this probability x is equal to x, we know that on a single value the probability is always equal to 0. So that's why I can remove this equality sign here. So this means what? So this is probability of x is less than 0.2. So this means I can write here the probability of x less than 2 mean I can write f of 0.2. Okay, this is same thing like this one, probability x is less than 0.2 mean. So we are going to find f of 0.2. Okay, what is f of 0.2 mean? So where is the 0.2 lies? You can see here, because the 0.2 lies in the second interval. How? Because this is x is greater than equal to 0. So this means I can pick this function. So I can write 1 minus e raised to the power, you can see minus 8x. So I can write minus 8 into 0.2. Right, when you calculate this expression, so we have this solution 1 minus e raised to the power minus 1.6. This implies when you calculate everything you get 0.7981, right? This is my part number 1. And you can see in the part number 2, so I will use the probability distribution of x. So look at this formula, we have already learned this formula. So how to find probability density function from the cumulative distribution function. What is mean by this one? Whenever you have given the cumulative distribution function, so you can find the probability density function by taking the derivative of this CDF, right? So I will use this formula. So d by dx of capital F of x is equal to small f of x. So in the second part, I will use this formula here. So in the second part, we know that if we are taking the derivative of capital F of x, right? I mean, if I am taking the derivative of d by dx of this capital F of x, this is equal to small f of x, right? You know about this one. And you can see here what is the value of capital F of x. So you can see my capital F of x is 1 minus e to the power minus 8x. So this means I can write d by dx of, so the capital F of x is 1 minus e raised to the power minus 8x is equal to small f of x. Now what is the derivative of this function? So when we take the derivative, the first number is 0, you know that this is 0, and this would become plus, right? It become plus, and what is this one? This will be, you can write 8 into e raised to the power of minus 8x is equal to f of x, right? And you know this, remember this formula. So here I am writing, so the differentiation of any exponential function, I mean e to the power of ax, is equal to a time e to the power ax. So here I am using this formula here. So this means what? So my small f of x is equal to a time e raised to the power minus 8x, and whenever x is greater than equal to 0, right? So what is meaning by this one? So what is my PDF? I mean the cumulative distribution function. So I can write here 8 e to the power minus 8x whenever x is greater than equal to 0 and 0 otherwise, right? So this is my probability density function, right? So here I will use this concept because we require the waiting time less than 12 minutes. So in this case, I will find here the probability of x is less than 0.2, because this is a PDF now, and you know that whenever you have given a PDF, so you can use this formula. So because I will integrate this function, x less than 0.2 mean I will integrate minus infinity to 0.2, and my function is this one, 8 into e raised to the power minus 8x into dx, right? So you can see there is a constant. Okay, so I can write this constant here. So I will integrate this function e raised to the power minus 8x, and you know very well the integration is e raised to the power minus 8x over minus a, and I will use this integration from minus infinity to 0.2, right? Okay, the one thing is important here. What? Because you can see minus infinity to 0.2. So there is a trick here, because the lower limit is 0 here, you can see. Okay, so how I can replace this one? Because you know that I can also write from 0 to 0.2, not because you can see my starting value is 0 here, my lower limit is 0, and up till 0.2. So you can see where is 0.2 lies. So you can see 0.2 lies is somewhere here in this interval, right? So the upper limit is 0.2 and my lower limit is basically 0. So now in this case we can replace this minus infinity by 0, right? So now here there is 8 and 8 will cancel out, so we get minus 8, right? And I can also write here what? This would be 1 over e to the power of 8x, and the limit is from 0 to 2. Okay, so I can put all these limits here. So this means there is a no minus 8, because the 8 and 8 will cancel out, so there is only negative sign here, right? So just we put the limits here. The upper limit we will put 2 here, so we get 1 over e to the power 16. So I can write 1 over e to the power of 16. When you put 0 here, you get 1, because something power 0 is 1. So I can also write like this one, minus e to the power minus 16 minus 1, and also I can write when you multiply by negative sign, you get 1 and then minus e to the power of minus this 1.6. This is not, I think, 16. I can check here. This is 8 e to the power minus of 8x. Yes, this is fine. This is 16. No. Why? Because, sorry, I have a mistake, because we are putting here 0.2. You can see the limit is 0.2, not 2. So here I am writing the wrong thing. This is not 2. This is 0.2 here. So when you put this limit here, this will give you 1.6, not 16. Sorry. So this is 1.6 and this is minus 1.6. So here I can write minus 1.6. And you can see here, this is the probability of x is less than 0.2, and you can see which is the same as over previous one. You can see, because if you look at here, so my previous answer is, you can see 1 minus e raised to the power minus 1.6, right? So this means this is the same answer, 0.7981, right? So I can write here this is equal to 0.7981, right? Thank you very much for watching this.